Hey everybody, test review time. Alright, we're solving proportions, cross multiplying, parentheses, save lives. So in step 1, I've got 4 times x plus 2 equals 3 times x minus 5. Hashtag distributive property, so 4x plus 8, 3x minus 15. And now let's maybe subtract 3x from both sides. And then subtract 8 from both sides. So I would have, let's see, x equals negative 15 minus 8 would be negative 23. Okay. Next one, parentheses, save lives. So I've got 4x equals 6 times x minus 2. When I cross multiply, then 4x equals 6x minus 12 after distributive property. Subtract 6x from both sides and get negative 2x equals negative 12. Then divide by negative 2 and get x equals positive 6. Cool. Alright, given the picture below, are the two triangles similar? If so, give the similarity statement and state the theorem or postulate that proves similarity. So this is going to be one of our three, either AA, SSS, or SAS. If not, explain why not. Okay, so I see these two arrows, meaning I've got some parallel lines. With parallel lines, I might extend these a little bit. I look at this angle and then angle C having to be the same because they are opposite interior angles. Similarly, haha, pun, I've got my two vertical angles in the middle that would have to be congruent. So each of those have two angles in common. So yes, similar by A. So that's the theorem or postulate. I still have to do my similarity statement, which would be triangle, let's see, A goes with D. Neither of those have marks. B has two little marks and C has two little marks. And then E is the same for both of them. So there's my similarity statement. Cool. Are the two parallelograms similar? If so, write a similarity statement and give the similarity ratio. If not, explain why not. Okay, so to be similar, I would need to have all the angles being the same size. Let's see. For the fun of it, let's say that the matching angles are the same, and we're going to start checking out our proportional side. So like if I do 4 is the short one over here, so 4 goes with 24 over there. When I do that simplification, I get 1/6. Yep, and then 6 goes with 36. Also simplifies to be 1/6. So based on the information, I feel like we probably should say no, since the angles don't have like little markings on them to show they're congruent or anything. But those two sides that we were given were actually in proportion. So let's say no, don't know if corresponding angles are congruent. Alrighty. In triangle ABC, AB is 4, BC is 7, and angle B is 40 degrees. Whoa, I'm just like, what the heck's happening? Gotta draw a picture to figure it out. Alright, so in triangle A, B, C, AB is 4 inches, BC is 7 inches, and the measure of angle B is 40. Okay, cool. Now I can kind of see what's going down. In triangle XYZ, so X, Y, Z. XY is 10, YZ is 17.5, and angle Z, or angle, whoa, XY is 10, YZ 17.5, and the measure of angle Z is 40. Are the two triangles similar? If so, state the theorem or postulate that proves similarity. If not, explain why not. This is a trick question. I think if you were just reading it, you probably would have gone and done a lot of math. But when I draw the picture, in order for me to use one of my theorems, the one that I'm thinking of using would be SAS. But for that theorem, the angle has to be included or between the two sides given. So I would need that 40 to be up here at angle Y. So just by looking at it, I can be like, all right, I'm not going to be able to use SAS because this has a donkey theorem, don't want to do that. I don't have enough to use SSS, and I also don't have enough to use angle, so this is going to be no, angle Z isn't an included angle. Which triangles are similar to triangle ABC? Whoa! Okay, so we've got a couple options here, and I'm probably going to need my calculator for these. 5 is the short side on triangle ABC, so that would go with 15 on this triangle. So 5 over 15 gives me a third. I want to check and see if these other guys give me that same relationship. So 12 is the second biggest, 36 is the second biggest. 12 over 36. Yeah, that also simplifies to be a third, so okay so far. And last one, I got to check out and see if 13 over 39 also give me a third. I'm not sure about that one. Don't remember my 13s times tables. I'm a disgrace to math teachers everywhere. Ooh, yay, it's a third. How exciting. So A is similar to triangle ABC. Got to check out this next one. So 2.5 goes with 5. The two short ones go together. So 2.5 divided by 5 gives me 1/2. Cool. 6 goes with 12. 6 divided by 12 also gives me 1/2. Cool. And then 6.5 goes with 13. And that also gives me 1/2. Cool. So both of those are similar to triangle ABC. Alrighty, what's up next? We have, in triangle ABC, AB is 5 inches, AC is 6.5 inches, and BC is 3. Whoa. Not sure what is happening. Must draw A, B, C. So AB is 5, AC is 6.5, and BC is 3. Okay. Triangle XYZ. XY is 19.5. YZ is 15, and XZ is 9. Cool. Are they similar? If so, write a congruency statement and state the theorem or postulate that proves similarity. If not, explain why not. Cool. Alright, so by looking at it, I think it's going to be SSS, but I'm not going to just write that down and then move on with my happy life. I have to actually check and see if the proportions are going to be the same. So 9 is the shortest side here. That matches up with 3, the shortest side over there. 3 over 9 is a third. Cool. 15 is the medium side over here. That goes with 5, the medium side over there. So 5 over 15. Oh, sweet. Also gives me a third. Looking freaking glorious so far. Let's see about the next one. So 19.5 goes with 6.5. Gonna need my calculator. So 6.5 over 19.5, yes, is also a third. So I checked them all, and I got the same fraction for each, so I do have proportional sides. So this would be yes by SSS, and then my statement, triangle blah blah blah, similar to triangle blah blah blah, Ooh, this is going to be rough. Okay, so 3 and 5 are the two short ones on this triangle. 15 and 9 are the two short ones on this triangle, so B goes with Z. It's not always going to be A, B, C, and X, Y, Z, good people. C is in between the little one and the long one. Over here, X is in between the little one and the long one, so C goes with X, and then by default, A goes with Y. You could have yours in a different order as long as the corresponding ones match up. Alrighty, next one. So find DB, there's our unknown, if AD bisects CAB, and AC is 12, CD is 4, and AB is 36. Cool. So I had to put that information in the picture. I should know based on one of our theorems that 4 over 12 equals my unknown over 36. I could cross multiply, or I could just think about, okay, 4 times 3 gives me 12, so what magical number times 3 gives me 36? That would be my good friend, the number 12. Cross multiplication should get you the same answer, though. Alrighty, in the figure below, B, C, and DE are parallel. That's why we've got these little triangles. AB is 1 yard, BD is 2x plus 3 yards, AC is x yards, and CE is 2 yards. Whoa, find x. So we should have 1 over 2x plus 3 equals x over 2. Oh my goodness gracious. When I cross multiply, I get 2 equals 2x squared plus 3x. And I am panicking because I'm going to have to factor. Got to go back in the memory banks and think about how to do that. Alright, so I'm going to do this by sort of testing out some numbers. I know that the only way to get 2 is by having 2 and 1. Same thing here. So one of these guys is going to be 2x, the other one is just going to be x. 1x. Let's see. And then I've got to have, let's see, if I want to have positive 3, let's try out maybe plus 2 and minus 1 and see what that would get us. So 2x times x would give me 2x squared. 2x times 2 would give me 4x. Cool. Negative 1 times x would give me negative x. And then negative 1 times 2 would give me negative 2. When I combine those like terms in the middle, I would get positive 3x. Okay, cool. So multiplying those binomials out by FOILing was a good little way for me to check and see if my work was right. Cool. So now I'm actually going to get two answers. One of them should make sense and the other one won't make sense. So I've got thingy number 1 times thingy number 2 equals to 0, meaning that one of those two binomials, one of those two thingies has got to be equal to 0. So either 2x minus 1 equals 0 or x plus 2 equals 0. When I solve this one, I get x equals negative 2, and when I solve this one, I get x equals 1/2. Now, when I look up here, it wouldn't make sense to have a negative number for x, or to have a negative length, so I'm going to go with this guy being my value of x. You also could have solved this guy right here in your calculator. If you didn't want to factor. Alright, find the perimeter of DEF if ABC and DEF are similar to each other. Whoa, okay, so before I can find the perimeter or the distance around this thing, I've got to find my missing sides. Let's see. Just to be sure, ED, or DE right here, matches up with AB. So my scale factor would come from doing 10 over 6. If I want to find EF first, 10 over 6 should be the same as 12 over my little guy over there that's missing. Calculator! So I would have 12 times 6 equals 10x, then I'll divide that answer by 10 and get 7.2. I'll do a similar thing to find out my next unknown, which is df. So 10 over 6 shows me the relationship between the two triangles. I know that triangle ABC has a length of 18 on one side. Got to figure out what's missing. So for that proportion, I would have 18 times 6, which is 108, divide by 10 to figure out what x is all by itself, and I get 10.8, right? Yeah. Okay, so now that I know my two missing sides, I'll add them all up to find my perimeter. So perimeter equals 7.2 plus 10.8 plus 6. Okay, so if I take that 0.8 and put it over here, I'd have 8 plus 10 plus 6, or 18 plus 6, which is 24. Alrighty. Find the value of x for these two problems. I'm assuming that since this is hang on, I see an angle here and an angle here that's the same, an angle there, an angle there that's the same. So I do know that those two triangles are similar by angle, angle. So I could set up a proportion like, let's see, this involves Pythagorean theorem, which we haven't learned yet. Oh my gosh. What we're going to have to do, maybe either skip this one, or if you're interested in the Pythagorean theorem, we know from our Pythagorean theorem, c squared equals a squared plus b squared. On this first triangle, c is our missing length, and then a and b are the two sides. So c squared equals 4 squared plus 3 squared. C squared equals 25. So c, or the length of that hypotenuse that we're missing, is our good friend, the number 5. Now I could go figure out what x is. I know that the relationship between this side and its matching side, scale factor is 2. 4 times 2 gives me 8. 5 times 2 would get me 10. Over here, b, we can do 24 over 6 should give me the same fraction as x over 9. Whoa, there's my cat and dog again. Let's cross multiply. So 24 times 9 is 216, which equals 6x from cross multiplying the other side. 216 divided by 6 gives me 36. Cool. Tricky, tricky, tricky. Mr. Childress decided he wants to know the Statue of Liberty's height. He places a mirror on the ground 152.5 feet away from the base of the statue. He then walked backwards until he could see only the very top of the monument in his mirror. He was 3 feet from the mirror at this point. Using similar triangles, how tall is the Statue of Liberty? Cool. So here are my two similar triangles. I know they're similar because they've got 1, 2 angles in common. And the height of the Statue of Liberty goes with the height of Mr. Childress. That relationship should be the same as the 152.5 over 3. Let us cross multiply. So 6 times 152.5, and then divide by 3. 305. Cool. Sounds reasonable. Ooh, spooky. We're having to deal with the coordinate plane. ABC has vertices 2, 2, 2, 4, and 5, 2. XYZ has two vertices, negative 1, 0, and negative 7, 0. Give 8 possible coordinates of vertex Z. Assume the two triangles are similar and disregard the order of the letters. Okay, So let's start by maybe graphing ABC. So 2, 2 would be here. 2, 4 would be here. Cool. And then 5, 1, 2, 3, 4, 5, 2 would be right there. So I'm going to make triangle ABC that dark one right there. So we've got a length of 2, a length of 3, and then this guy, which would end up being something decimally. I'm going to start drawing x, y, z in another color. So I've got -1, 0, which is right here, and -7, 0. 1, 2, 3, 4, 5, 6, whoa, 4, 5, 6, 7. Okay. So I know that that red is going to be one side of my similar triangle. It's 6 units long. So let's pretend for a second that that 6 right there, we're going to be corresponding with the 3. So if the 6 corresponds with the 3, then if the other side is 2, on my red triangle, I would need to make something, let's see, 12. I would need to make something that's 4 units long. So I see a right triangle here, meaning that this similar triangle should also be right. So to get some of my points, I could go up 1, 2, 3, 4 units. That guy would give me a similar triangle. I could go down 4 units, 1, 2, 3, 4. There's another similar triangle, or I could pretend that it's like a flipped over version. So I could go up 4 right here, and that would give me a similar triangle, or down 4. And I'd also have a similar triangle there. So there's 4 different similar triangles. Let me write those vertices down. I've got -7, 4 for that one. I've got -1, 4 for that one. -7, -4, and -7, or sorry, -1, -4. Alright, so those 4 points came from me matching up the 6 with the 3. Now, the other points that I'm going to get, the other 8, are going to come from me matching up the 6 that goes between the 2 points they gave me with that side that's 2. So if 6 matches up with 2, then the side that's 3 would have to match up with, let's see, 3 times 6 is 18, 2 times x is 2x, and then divide by 2 on both sides, I would get 9. So the blue is going to stay, that's my 2 points that I know, and then I'm going to need to go up and down 9 spaces from both of those dots. So 1, 2, 3, 4, 5, 6, 7, 8, ooh, it's going to go off the page, 9 up here, there's one of my dots. So that triangle would be similar to that one, it's like a rotated version. So that point is at -7, 9. I could also go down 9, so that point would be at -7, -9. Then I could go up on and down on the other side. So I would be at -1, 9 up there, or at, like that triangle would be -1, -9. So here are my 8 points. That was a tricky one. 13. Determine if the triangles are similar. If so, state the postulate or theorem that you used, write a similarity statement, and write the similarity ratio. If not, explain why not. Okay, so it looks like it's going to be side, 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 but I can't tell for sure. I have to first set up my proportions. So 5, the short one, goes with 10, the short one. 5 over 10 is a half. Cool. 6, the medium one, goes with 12, the medium one. So 6 over 12 is also 1/2. Word. Oh snap, hang on. 8 is the big one and 15 is the big one. But guess what? 8 divided by 15 is not a half. So we've got not similar because not all those sides are in proportion. Alrighty. So now we're up to our proofs. We're given some parallel lines and we want to prove that those two triangles are similar. Alright, so the first reason is going to be given. The next thing they tell me is that angle NML, which is this guy, is going to be the same as NPO, which is that guy. Cool. Those two would be my corresponding angles. So they would be congruent when I have parallel lines. If I'm using the reflexive property, that means I'm saying something is congruent to itself. My whole goal is to prove that these two triangles are congruent, and when I look at what they have in common, the thing that they would both have would be this guy, angle N. So I'll say angle N is congruent to itself by my reflexive property. Last part, what I'm trying to prove should be the last thing I write down. So triangle MNL is similar to triangle PNO. Well, I have 1, 2, and 1, 2 angles that they both have in common, so that would be my angle postulate. Alrighty, another proof. We are given some right triangles. So ABD and ABC are right triangles. It might be a good idea to draw triangle ABD out separately. So there's ABD and its right angle. And then maybe I'll make in red ABC. So here are my two triangles that I'm dealing with. Alrighty. ADB, so ADB is this one, and ABC, that one, are the same. They're both right angles, so that would be all right angles are congruent. DAB and BAC are congruent. Those are both just two different names for the same angle. So that is my reflexive property. So if I were to call this thing DAB, or if I call it BAC, they're both naming this guy up here. And then when I look at what I've got, the reason that the two triangles will be similar, they both have two angles in common. So once again, angle postulate. Let's see, so triangle ADB, similar to triangle ABC. Oh, whoop, I guess I could have used my answer bank down here. My bad. Alrighty, so last page, here we go. Oh, these look gross, but it's going to be okay. We'll figure it out. So, I've got this gross, nasty looking shape right here. Let's see.
Alright, so an important thing to maybe mention is that you're not going to necessarily end up needing everything that's in this picture. I see like 2x plus 6 and 24. Something similar that I see over on the other side is the relationship between the 27 and the 36. So I'm going to go with those pieces of information. Now's where it gets gross. Cross multiply. So 2 times 36 is 72x. 6 times 36, I don't remember right offhand. 6 times 36, 216. and that should be equal to 27 times 24. 648. Alright, so I'm going to end up having to subtract 216. Whoa. 648 minus 216. And then divide by 72 to get that x equals 6. Alrighty, moving on, look at 17. I could do the same kind of thing. Here's the x, what I need to figure out, what I don't know. I see over there 10 and 5x plus 15 is like the whole length. On the opposite side, I see 12 is the little one, and then 96 is the whole length. So those relationships should be the same. Let's calculator it out. So 10 times 96 would be 960. 12 times 5 would be 60x, and then 12 times 15, that one I don't know, 180. Okay, so 960 minus 180, and then divide by 60. So x equals 13. Cool. Two more of these. I have 12 and 28, so 12 over 28, that should be the same relationship as 2x minus 13 over 35. Calculate it out. 12 times 35 is 420. Is that what that was? Yep. Over on the other side, 2 times 28 would be 56x, and then 13 times 28, no, 13 times 28 is 364, so 420 minus, oh wait, plus, holy goodness, 420 plus 364, and then divided by 56. 14 for that one. And finally, 3x over 96 should be the same as the relationship between 18 and 48. And 3 times 48 equals 144x. 18 times 96 equals 1,728. I'll divide that by 144 and get x equals 12. Sweet. So the last ones are just our review of distance, midpoint, and slope, which will be on all of our tests from here on out. For A, they're giving me 2 dots off of the graph, and for B, they're giving me the actual coordinates. So for the distance on A, I'm going to just use the Pythagorean theorem, actually. Oh! If I can get this thing to work. Oh my goodness gracious. The other option, if you don't want to use the Pythagorean theorem, would be to figure out what point A and point B are, like what their coordinates are, and then plug into the distance formula. So I see that the length over here on this one side is 1, 2, 3, 4 units. Over here, it's 1, 2, 3, 4, 5, 6, 7 units. So to find the distance, or the length, c squared equals a squared plus b squared. And then to get rid of the squared, you'd square root. So I would have 7 squared plus 4 squared, or 49 plus 16. Let's see, so I'll take a 1 from there, make it 50 plus 15, which would be 65. Square root of 65. Cool. Midpoint, I'm going to take the two x values, add them together, and divide by 2. So here it might actually be kind of helpful to figure out what my coordinates are. A is at -3, -2. B is at 4, 2. So for the midpoint, I would do 4 plus -3 divided by 2, which is 1/2. Then for the y-coordinate, I would do -2 plus 2 divided by 2, so that's 0 divided by 2, or 0. There's my midpoint. Slope, I've got y minus y, so 2 minus 2, x minus x, 4 minus 3. So 2 minus 2 is 4, 4 minus 3 is 7. So right there, 4/7 would be my slope. Notice it's positive, which makes sense because that line is going up from left to right. For part B, distance formula, x minus x, so 8 minus a minus 3. Notice this is an x and this is an x. Whoa. Square that answer. Plus y minus y squared. 8 plus 3 is 11 squared. And then -2 minus 4 is -6. Look at my parentheses. Parentheses save lives. So I've got 11 squared, which is 121, plus, notice, -6 squared is going to be positive 144. So I'm going to add those two suckers together. 121 plus 144. Oh! Why does it keep doing that? Ah! 144 plus 121. There we go, 256, or 265. And I can square that and get about 16 as my answer. 16.3. But either of those will work for distance. Midpoint, x plus x divided by 2. Y plus y divided by 2. And simplify. So 8 minus 3 is 5 over 2. -2 plus 4 is 2 divided by 2, which is 1. So there's our midpoint. Last one, slope. Y minus y, x minus x. 4 minus 2 is 6. -3 minus 8 is -11, so there's my slope. Okay, 21. Given y equals -2x plus 5, write the equation of a line that's parallel and goes through this point. When I'm writing equations of lines, I want y equals slope times x plus my y-intercept. If I want something parallel to this one, I want the same slope. So I know that I want -2 to go in the position of m. I don't know what the b value should be, though. However, I have this point that I can use to help me. So I'm going to take that -3, 4, and substitute it into the equation that I'm building. 4 is the y value. -3 is the x value, and I don't know what b is. So 4 equals 6 plus b. Think about it. 4 equals 6 plus some magical number. That magical number better be -2. That's what I'll put in for b. And I'm done. Whoa! Got excited there. So this guy is my answer. Next one, write an equation of the line perpendicular. So almost the same, except for, instead of putting -2 in the position of the slope, I want the opposite reciprocal, which would be 1/2. It's going to be a different value for b as well. So in the equation that I'm building, I know that I can use -3 for x. So I'll pop that guy in there. I know that I can use 4 for y. What's next? That's a lot. And I'll solve it. So 4 equals negative 1.5 plus b. So I'll add 1.5 to both sides, and I'll get that b equals 5.5. So that's what I'll put over here. And I'm done.